Hi kids, we'll be going into this paper discussion. You can look at the first question. A thin uniform rod of length L is rigidly attached to a thin uniform semicircular ring of same linear density to form a rigid structure. The system is hinged as shown, and at equilibrium the rod is horizontal. The distance of the center of mass of the system from the hinges. Now if you draw the free body diagram of this total system, there will be hinge forces and there will be weight. As it is in equilibrium, net force should be 0, net torque should be 0. Net force can be 0, it will be managed by hinge force. Now if you take torque about this point, those torque due to those forces will become 0. The only external torque is torque due to weight that should be passing through that point, or I can say the total center of mass of the system should be somewhere along this line, somewhere along that line. Then if I want to find total center of mass, it will be somewhere along this line. If I take this is my x-axis, this is my y-axis, center of mass location, x coordinate should be 0, only y coordinate should exist. So total mass into position vector of center of mass equals to m1 r1 bar plus m2 r2 bar. Total mass, this mass is lambda into pi r, lambda into L. Now this mass into this position vector of center of mass, it is 2r by pi along x-axis and minus r along y-axis. And for this one it is minus L by 2 along x-axis and minus 2r along y-axis. So that's the only thing. After that you will be calculating what is the position of the center of mass. Now x coordinate should be 0. When you equate this to 0, you will get the relation between L and R. Then when you substitute it back here and here, you will be getting y coordinate of center of mass, right? A cubical container, material of thermal conductivity K of side A and thickness x is suspended in air and filled with n moles of diatomic gas. Adiabatic exponent is gamma in a room temperature T0. If at time T equals to 0, the temperature of diatomic gas is T1. Then the temperature of the gas at any time is given by. Okay, so basically I should have written a reverse here. Heat will be flowing from inside to outside. So now if there is a conductive material, if there is temperature difference, then the rate at which heat will be flowing will be K into area by thickness into temperature difference T minus T0, but there are 6 phases, so 6 times. Now that will be constantly reducing this temperature, so you will be getting minus Nc dt by dt. Minus and minus will get cancelled and it looks like this, right? So from there you have to do the integration. Now this dt I can write it as d of t minus t0 such that it looks like simple equation for me. Now this is like dn by dt equals to minus lambda n form. So I know the solution. The solution is that number is equals to initial number into e power minus lambda t, right? So where lambda, you can understand from here what is lambda. So the only thing is writing this equation, writing that equation. Whatever heat is there, that is changing the internal energy because work is not there. Two bubbles contain the same ideal gas at the same temperature such that one is trapped inside the other. The system is kept in vacuum. Ratio of densities of the gas in the inner and outer bubbles is x, and the ratio of the number of moles in the inner and outer bubbles is y. Find x by y. So pressure difference for a bubble, there are 2 interfaces. For each interface there will be, so bubble here, 2 interfaces, A to soap solution to air. So 2 times of 2T by R. So pressure difference will be 4T by R, 4S by its radius. From here to here the pressure difference will be 4S by R. So this pressure will be 2S by R, this pressure will be 4S by R more than 2S by R, which is 6S by R. Then if I use PV equals to nRT here, I will get this equation. If I use PV equals to nRT for this gas, I will get this equation. Then if I take the ratio, I will be getting the number of moles, and at the same time you can take this volume here, then you will be getting rho RT by M, Then when you take the ratio, you will be getting 6 by 2 is 3. So densities ratio will be 3. Then they were asking what is the ratio of those two. ABC is a spherical wavefront centered at O. It is incident on slits S1 and S2 such that BS1 is given as 3 lambda, S1 S2 is given as 4 lambda, B1O is given as 6 lambda, S1E is given as 128 lambda, and a mica sheet of refractive index 1.5 is placed in front of S2. The minimum value of the thickness such that central maxima is formed. I think it's not minimum value, it's only one value. Central maxima is formed at E is So this is the spherical wavefront. If slits were not there, the spherical wavefront is going to converge at O, centered at O. So they are going to converge at O. So if that slits were not there, like this would have become some other radius, this wavefront would have become this wavefront and it would have converged here. Now this wavefront, when it is becoming this, so these 2 points will be in same phase. These 2 points will be in same phase. Now given distances, this is 3 lambda, this total is 6 lambda, so this will be 3 lambda. If this is 3 lambda and this is 4 lambda, this is 5 lambda. So 5 lambda here and 5 lambda here, they will be in same phase, same phase. So this one and this one will be in same phase. Now whatever happens here will happen here in future. So this is leading over this. By how much path difference? By how much path difference? This is 2 lambda. So this is leading this one by path difference of 2 lambda. So if I take the phase here, if I take this as my reference phase, this phase will be ahead by 2 times of lambda, which is 4 pi. So if this is ahead, then this is also ahead. Right, anyway, that's not really much needed to do the calculation. Okay, I think we need to talk about central maxima, right? So this is ahead. Now if it is having an extra path, it is going to lag here. So it is ahead by 2 lambda, so it should lag here by 2 lambda. Anyway, or else I can say like from here, this is going and hitting here. So this path reference is 128 lambda plus 2 lambda. That path reference should be same as this path reference, because we understood these two will be in same phase, right? So this path reference, that is going to be root of 4 lambda square plus 128 lambda square, but that is going to be the length, but out of that some thickness you have to remove because you are putting mica sheet. So out of that length you have to remove t and you have to replace that with mu into t. So that is going to be the optical path length. If this optical path length is equal to this optical path length, then it is going to be central maxima, right? And you need to solve for it. That's the only equation. And this question already came in some of your exam, so I am attaching the same solution. But anyway, if you didn't understand back then, you won't understand now also. You can, it's based on only symmetry and Ampere's law. You can try by yourself. A uniform rod, not this one. A uniform rod AB of mass m and length L is fixed. A point mass is released at rest from point C. As shown in the figure, the speed of the mass is found to be something when it is at a distance L by 2. Because of the attraction, it will be increasing its speed. You need to calculate what is its speed when it is here. So what I will be trying to do is I will be trying to find how the gravitational field is going to behave at any random distance. At any random distance L, if I want to find what is the gravitational field because of the rod, I have to integrate. I will be taking some element at a distance x, which is dx. I will be finding field because of this element here, that is going to be this much. Now if I want to find the field because of the total rod, then I have to integrate from where to where? Small l to small l plus capital L. That is going to be the field magnitude wise, and it is attraction. So because of that, if it starts moving, then the work done by gravitational field is going to be gravitational field times small displacement, and I have to integrate this. Now according to the given question, that small l is varying from capital L to L by 2. I just need only magnitude. Understand there will be negative symbols and all, but I know work done by gravitational field will be positive, which will be going as kinetic energy. So you have to integrate from L by 2 to L. That will give you half mv square. I have taken unit mass, or I am talking about field. So field dot dx, work done by field, is going to be half v square, right? So this is going to be half v square, so v square is going to be 2 times of that. A small ball of mass m is placed in a circular tube of negligible width and mass m and radius r, which is kept on a smooth horizontal plane in gravity free space. Friction is absent between the ball and the tube. Ball is given a velocity v naught. Choose the correct options. So the path of the ball relative to the center of mass. So center of mass, it will be, if it is somewhere here, when you observe from center of mass frame, this momentum and this momentum will be same. So and angular momentum, net momentum will be 0, angular momentum will be conserved, and center of mass is not going to move, so this distance and this distance will remain same. The scenario will keep repeating by changing, by the figure looks like rotating the figure. Center of mass doesn't move and distances also doesn't change. Right, so basically it is going to be circular, not elliptical. Then if you want to find radius of curvature relative to ground, now center of mass frame is also not accelerating. Center of mass frame is moving with a constant velocity mv0 by m plus m. Now if I observe from center of mass frame, this velocity is going to be v0 minus velocity of center of mass, which is going to be this much, and this velocity is going to be small m into v0 by capital M plus small m. Anyway, center of mass frame is also moving with constant velocity, so acceleration in ground frame and center of mass frame should be same. So in center of mass frame, I know this is going to perform circular motion of radius this much. That location is capital M into r by capital M plus small m. So this is going to perform circular motion of this much radius. So net force towards the center should be equals to m velocity in center of mass square by radius of curvature in center of mass. Now this is the force acting in center of mass frame. That should be the same force acting in ground frame also. In ground frame, velocity is v0, so radius of curvature in ground frame is r. Force in ground frame and force in center of mass frame, they were same because center of mass is not accelerating. When you solve it, you will get radius of curvature. Then they were asking normal force. So basically, who is providing this? Normal. So they were asking what is this when you substitute capital M equals to 2 times of small m. Substitute capital M equals to 2 times of small m, you will be getting option D. A tuning fork of frequency 1000 Hz is sounded over a resonance tube as shown. Okay, so speed of sound is given, area of cross section is given, at a depth 100 centimeter. A water outlet is attached which has a cross sectional area of 1 centimeter square and is open at t equals to 0. That this area is very small when compared to this. Frequency is given, speed of sound is given, so you can get the wavelength. Now when you keep dropping the water column, the first resonance is going to happen when this length is equal to lambda by 4, second time 3 lambda by 4, 5 lambda by 4, that is when it has dropped by distance of 8 centimeter, 24 and 40, which is going to give you option A. Option B is wrong. Then what is the time taken to drop? First resonance occurs. So roughly the formula, in order to remember the formula, like you can do roughly the calculation of time taken to empty the tank, which is easy to remember, though it is not correct, but remembering this is going to help us in making out this formula easily. So remembering that formula is going to make me understand time taken to empty the total one is this into this, where h is 100 centimeter, and time taken to empty from 92 centimeter is this much. So time taken to go from 100 centimeter to 92 centimeter is difference of those two. The same idea is going to happen for the next one also. I am borrowing this result from here, though it is not exactly correct, but it is useful to get it there. A hexagonal prism, anyway, so it is when steady state is achieved. When steady state is achieved, capacitors will be open circuit. And you can see here there is a closed path here and there is closed path here. Only current will be flowing in those two. Now, if you write the loop equation here, I didn't write, but when you write the loop equation here, it looks like plus E minus I into R, plus E minus I into R, plus E minus I into R. When you do that, you will get the current there is 5 ampere. You don't get any loop equation here because there is no resistance. So this current is going to be 5 ampere. Similarly, if you write the loop equation here, you will be getting this current is 1 ampere. Then if I take this potential is 0, then plus E minus IR, that will turn out to be again 0, 0, 0. Similarly, if you apply I into R here, this potential is going to be minus 2, again plus E minus IR, or you can go from here to here, that potential difference is going to be 2. If this potential is 0, this will be 0 because no current is flowing in this. Similar fashion, this is 0, 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 this is 0. Then this capacitor is between 2 and 0 volt, so potential difference is 2. 4C, C is itself is given as 2 micro, so this is 8 micro. 8 micro is between 2 volt, so it is going to be 16 micro. Similarly, capacitor C, this is between potential difference 0, so there won't be charge. Going to the next question. A conducting coil, I think this question already came somewhere, I am not sure. A conducting coil, one named ABCD, shown as a part of imaginary cube, has a self-induction coefficient L1. Another coil 2 is having induction coefficient L2. Then they were asking some questions. So basically this induction coefficient is L, the meaning is if you pass the current I, the flux passing through this is L1 into I. So that's a very straightforward question. The self-inductance of this structure is L2. If you pass the current in this, the flux passing through that is going to be L2 into I. But you can see this by adding a current and subtracting current, you are not doing effectively anything. Now if you do this, if current is passing through this, then the flux through this because of its own current will be L1 into I. Because of this current, there will be flux in this, which is M into I. Similarly, flux because of this current in itself is going to be L into I, because flux on this because of this is going to be same M into I. But we already concluded this was L2 into I according to given in the question. So they were asking what is the value of M into I. M into I is going to be option D. Right, and so I am attaching the same question and similar two questions which you have already seen somewhere in the exams. So anyway, if you want to practice, you can look into them. In a RLC series circuit shown, the readings of the voltmeter V1, V2 are this much respectively, then you need to calculate stuff. So I am drawing the phasor. Generally I will be drawing the phasor for maximum values. So when I divide with root 2, I will be getting RMS. So here I am drawing for RMS. Basically I will be drawing for maximum and divide with root 2, that is my idea. If I take current as a reference, voltage in the resistor will be in phase, voltage in the inductor will be leading the current by 90 degrees, voltage in the capacitor will be lagging the current by 90 degrees. Now I will round up the values what I am going to calculate. This one I assumed, then this one and this one is going to come into picture, and they said voltmeter across resistor and inductor is going to read V1, which was 50, which was 50 root 2, which was 50 root 2. So 50 root 2 whole square is going to be 5000. So this square plus this square is going to be 5000. Similarly, resultant of these two, I don't know which is going to be bigger, so I am squaring it and I am saying that is going to be 120 square. Now similarly, resultant of these three is 130 RMS. So resultant of these two will be perpendicular to this, so it is going to be Pythagoras. This square plus resultant of this square is 130 square. This value is 120 square. When I substitute it here, I will be getting this value is 50 square. If I substitute this is 50 square, then I will be getting this is 50 square. Now if I understand this, I into XL is 50, but this is going to be 120. So the meaning is XC is greater than XL. XC is greater than XL. From there you will be getting I into XC is 170. Then you want to find, when I substitute these values here, and you want to find the power factor, this is 50 and this is 50. 170 minus 50 is 120. This is going to be 120. 120 and 50 is going to give me 130. They were asking cos of this angle. Cos of that angle is 50 by 130, 5 by 13. Two small blocks of mass m and 4m are connected to two springs as shown in the figure. Both the springs have stiffness K and they are in their natural length when the blocks are at point O. Both the blocks are pushed so that the springs get compressed by distance A. First the block of mass m is released, and after it travels a distance of something, second block is released. Now where they are going to hit and at what time they are going to hit. Both are going to perform SHM with amplitude A. So we are trying to represent both of them in the same phasor diagram. You are leaving it. When you leave it, it will be going this way. Which I am seeing it as circular motions, projection along x-axis. Understand this omega and this omega are different. This omega is root of k by m. This is root of k by 4m. So if this is omega, this is going to be omega by 2. Now we are leaving it here. It is going to go this way. just for better understanding, instead of taking clockwise, I am going with anti-clockwise. Anyway, if it goes like this, its projection will go like this. So I can take clockwise or anti-clockwise according to my convenience. Now, where are they going to meet? They going to meet somewhere here, is same as these two circular motions meeting here, or this angle rotated plus this angle rotated should be this total angle. They gave this distance is root 3 by, they gave this is a minus root 3 by 2a. The meaning is this is root 3 by 2a. If this is root 3 by 2a, this angle is 30, so this angle is 150. So this angle rotated plus this angle rotated should be 150. The meaning is this angle rotated omega by 2 into t. From there you will get after what time they will be meeting. Now in that much time, angle rotated by the green one is going to be 5 by 18. So if it is rotating by an angle 5 by 18, its projection is going to be a cos 5 by 18. So x coordinate is going to be a cos 5 by 18. So they will be hitting at this location. A system of coordinates is drawn in the medium of refractive index. A ray of light is incident at origin. I think this kind of questions you have seen not many. It's like refractive index is varying with y coordinate. So they are like slabs. So mu sin theta at any slab is going to be constant. So mu sin theta here will be same as mu sin theta there. These kind of questions are very common, you can expect in the exams. So mu sin theta initially is equals to mu sin theta at any location, but they were talking about grazing angle. That is, with normal it is making 90 degrees. I think that's a pretty easy question, maybe little calculation is needed. A rectangular frame of negligible resistance with capacitor of capacitance is placed near infinitely long wire carrying current. Current is varying with time, so magnetic field here will be varying with time, flux will be varying with time, and there will be induced electric field. Magnetic field is varying with time, it will be creating induced electric field, which will be creating an EMF, which will be driving the charges. So they are asking what is the charge on the capacitor. So whenever there is induced electric field, we have only one option, calculating flux and rate of change of flux. So if current is I, at that moment flux, if I want to calculate, magnetic field is varying with the location, so I will take a strip at a distance x. At a distance x, the thickness of the strip is dx. So magnetic field there is mu naught I by 2 pi x, and area of that strip is going to be 4 times of dx. When you integrate from x is varying from 2 to 4, you will be getting the flux. But you can see current is varying with time, so flux will be varying with time. Rate of change of flux magnitude wise will turn out to be EMF. I was given in the question, so di by dt will be this much. But they were asking what is the, now what is this EMF going to do? When you write the loop equation, EMF minus q by c is going to be 0. So q is going to be c into E. So E value at t equals to 0 is going to be this much. When you multiply with capacitance, you will be getting what is the charge on the capacitor. So flux, rate of change of flux will give you EMF, C into E is going to give you the charge on the capacitor. S is a neutral conducting sphere. A point charge 1 micro is placed at A and C is the center of the sphere. AB is the tangent, BC is 3 and AB is 4. The electric potential at B due to the induced charges. There is this charge, this distance is 4, 3 and 5. And because this is positive charge, there will be some kind of negative induced charge, positive induced charge, but we know overall charge is going to be 0. The good thing about the center is it is equidistant from this negative charge as well as positive charge. So potential because of this and this is going to cancel here, which is going to be 0. Potential because of this charge here is going to be k into 1 micro by 5. So potential at C because of this charge is going to be k into 1 micro by 5. Due to induced charges will be 0. So net potential is going to be this much. And if you want to calculate at B potential because of this charge is k into 1 micro by 4. Due to induced charges, you don't know what it is, so I am calling it as x. So potential at B is this much, but we know it is conducting material, so potential should be same in electrostatics. So these two should be same. From there you can get the value of x, which is minus 450. They were converting it into kilo. The length of the pencil is measured by a vernier caliper. Least count is something given. Okay, so let me show you the figure and explain what is the scenario. So the length of the pencil is being measured. It is placed like this. Vernier scale has n divisions, n vernier scale divisions which are coinciding with n minus 4 main scale divisions. From there you will be getting one vernier scale division is how much mm. how much mm, and vernier constant is defined as 1 MSD minus 1 VSD. 1 MSD minus 1 VSD is going to be 4 by n mm. So that is vernier constant, but generally that is going to be least count also. So if we assume that is going to be least count, they gave this value is 0.05 mm, the meaning is n is 80. N is 80, if n is 80, this is going to be 76 and 80, so that is going to be 0.95 mm. 1 VSD is 0.95 mm. So you can see 2 VSD is going to be 1.9, 2.85 and so on, and it is going to become 19. So you can see the difference between this number to the nearest integer is 0.05. Between this number to the nearest integer is 0.1. So when you look into that, least count is going to be 0.05, which is same as vernier constant. Anyway, so taking that for granted, that is going to be the least count. Now we need to measure what is the length of this pencil. You can see here, this is 84 millimeter and something more than 84. So if you are marking, you should be marking 8.4 something. 8.4 something. So the probability of you getting that answer is much better now. 8.4 something. Now that's something you have to calculate. They said 16th division of vernier. So vernier 0 will be here. 16th division of vernier is coinciding with some main scale, 16 vernier scale divisions. One vernier scale division is this much, so 16 times of this is going to be 15.2 mm. If this is 15.2 mm, we understand this should be integer. This should be integer and slightly more than 15.2, so that is going to be 16. If this is 16, this is 15.2, this is 0.8. So 84.8 mm, that is 8.48 centimeter. In the photoelectric experiment, if you use monochromatic light, IV curve is shown, the work function is 2.35. Estimate the power of the light used given efficiency is 10 power minus 3 percentage. Percentage wise it is 10 power minus 3, so it is 10 power minus 5. So for 10 power 5 photons, okay, and I am attaching other vernier questions from here. So maybe in future, even if there is any vernier question, I may not attach any questions because I am attaching here 3-4 questions. Those who want to do the practice, you do it from here. Don't expect me to attach any more vernier questions in future. So saturation current depends only on the number of electrons coming out per unit time. So number of electrons coming out per unit time into charge of electron is going to be saturation current. From there you will be getting number of electrons coming out per unit time. But for 10 power 5 photons, there is only one electron coming. So how many photons were there? This into 10 power 5. That into 10 power 5 photons, and each photon energy is 7.35 electron volt. So those many photons energy will be this much. So which is 7.35 joules. You need to convert electron volt into joules per second. Joules in 1 second. These many electrons in 1 second. These many photons in 1 second. This much energy in 1 second per second. A block of mass m is kept on a rough horizontal surface. So let me read it by showing you the solution. A block of mass m is kept on rough horizontal surface and is connected to a dielectric slab of mass m by 6 by dielectric constant K by means of light inextensible string passing over the pulley. Dielectric can completely fill between the capacitor plates L by L, and the separation between plates is D, kept in vertical position. Initially the switch is open and the length of the dielectric inside the capacitor is B. Coefficient of friction between the blocks is 1 by 4, the minimum value such that it starts to move. So this is mg by 6, but the maximum friction here is mg by 4. So maximum friction is more than this, so it can't come down. So when you close it, because of the attraction, because of the induced charges and attraction between the plates and the dielectric, it is starting moving. The meaning is that extra force coming now plus weight of this thing is just overcoming the maximum friction. So basically that force by the capacitor plates is mg by 12. mg by 12. Now your voltage, you are increasing the voltage by 2 times. So I am attaching this thing where we calculated how the force is going to behave when battery is connected, which is going to be a constant force which is proportional to V square. Once you know it is constant, you can understand proportional to V square by dimensions also sometimes. So proportional to V square, if this is becoming 2 times, then that force is going to become 4 times. This force is going to become 4 times now. So that force and this weight both are pulling downwards and friction is opposing. So the net force equals to total mass m plus m by 6 into a. From there I will be getting acceleration is 3g by 14. 3g by 14. If it is constant acceleration, by the time it falls by distance L minus b, what is its velocity? From there you can get the value of y easily. For getting the value of y easily, you don't have to exactly know the formula. If you know it is proportional to v square, that is sufficient enough. Now they gave this thing, minimum voltage. So when I square it and when I bring it such that dimensions match, it looks like something like mg by x. But for that you should be knowing the exact formula. Exact formula is half into this thing. That is going to be the force. So this is going to be the force. That minimum force we understood was mg by 12. So x is 6. In order to find the value of x, you need exact formula, or else proportional to v square is sufficient enough. And there is this question which came in one of your exam, and some guy was trying to do it using just the basics. So I have attached that solution. Those who are not comfortable, why we went out of the box to calculate angular momentum, right?